Welcome to this segment. In today's segment, we are looking at differentiation. So let's do some brief introduction to differentiation. Now, differentiation is the mathematical process of finding the instantaneous rate of change of a function. In simpler terms, it calculates the slope of a curve at any single specific point. Now, we are going into the basic of differentiation, and the very first rule we need to learn for differentiation is what we call the power rule. The power rule is the most fundamental tool for differentiating polynomial terms, as it allows us to find the rate of change for any function where the variable is raised to a constant power. Now, the standard formula for the power rule is written as n x raised to power n minus 1, and this simply means that when we are differentiating a given variable, we have to multiply the whole variable by its power, then subtract 1 from the power. That is, we have to bring the exponents down to the front as a multiplier, then subtract 1 from the multiplier. Now let's look at some examples. Now we had the very first one, x raised to power 5. Now when we differentiate x raised to power 5, what do we need to do? We need to multiply the whole variable by its power, which is 5. So we are multiplying 5 times x raised to power 5. Then we subtract 1 from its power, which is 5. So we have 5x to the power of 5 minus 1, which gives us what? 5x raised to power 4. The same thing for the next one. We have x raised to the power of minus 3. The same thing, we multiply by minus 3, then subtract 1 from its power to give us minus 3x raised to power minus 4. For the last, we have root of x, which applies the same way, and we have 1 over 2x raised to power minus 1 over 2 as its answer. The second rule now is the constant multiple rule, and this rule, we use this rule when we have constants with a variable. So what we need to do is to separate the constant from the variable, differentiate the variable, then multiply back with the given constants beside it. Now let's look for the derivatives of 3x cubed, 5 over 2x squared, and 2 root x. Now we simply need to separate the constant during the differentiation, so we differentiate only the variable. For the first one, we have 3x cubed, so what we need to differentiate is x cubed. So we differentiate x cubed to give us 3x raised to power 3 minus 1 according to the power rule we learned earlier. So when we multiply 3 times 3x squared, it gives us 9x squared. Now the same for 5 over 2x squared. We keep 5 over 2 out, we differentiate x squared to give us 2x using the power rule. So we then multiply the constant back with it to give us what? 5x. Also for 2 root x, we separate 2, differentiate root x to give us what? 1 over 2x raised to power minus 1 over 2. Let's look at the sum and difference rule. Now, differentiation is often a linear operation, that is, the derivative of a sum or a difference is just simply the sum of each of the different derivatives. Now, we can differentiate a polynomial term by term using the formula below, which expresses the sum and the difference rule in differentiation, where we can have two variables fx and gx. When you add them, we just simply need to derive each of the given variables or functions, then add. Also for the subtraction, we also have the same rule. We differentiate each of the variables in the polynomial to give us the derivative of the function. Now let's find the derivative of the following polynomials: a, x squared minus 5x plus 6, b, 2x cubed plus 3x squared minus 5. So we have the derivative of x squared minus 5 plus 6 to give us the individual derivatives of the variables in a given function. So we derivate x squared to give us 2x. Using the power rule and the constant multiple rule, we derive the 5x to give us minus 5. And then we derivate 6. And in rules of differentiation, the derivative of a constant gives us 0. So final answer, we have 2x minus 5. Also for 2x squared plus 3x squared minus 5, we have the derivative to be, using the constant multiple rule, we bring 2 out, we derivate x cubed, and we have 2 times 3x squared, which gives us x squared. Also, using the constant multiple derivation, we actually derivate 3x squared to give us what? 3.2x, which gives us 6x. And then when we simplify that, it becomes 6x into the bracket x plus 1 as our differentiation. And in the next section, we'll be looking at the other rules of differentiation. We'll be looking at chain rule, we'll be looking at product rule, and we'll be looking at every other rules that are applicable in differentiation.